Hi everyone. Okay, so here's the video on graphing rational functions. So we're looking at rational functions and the graphs of them. There's some characteristics that we need to be aware of. So we're going to look at the vocabulary. So you see this vertical asymptote here. We have vertical asymptotes on rational functions sometimes, and some examples are here. And notice I'm using a dotted line because the line is actually not on the graph. It's an invisible line because asymptotes or vertical asymptote creates an undefined scenario along that entire line. So the function is not defined at all on those lines, on vertical asymptotes. So these are examples of vertical asymptotes. And here, okay? We also have horizontal asymptotes, same idea. There's an undefined scenario all along that line. So this is an example here of a horizontal. Again, we use a dotted line for that scenario because the function is not defined all along that line. We have x and y intercepts. So x-intercepts obviously are points on my x-axis. So these are examples of x-intercepts. My y-intercepts obviously are points that are on my y-axis, so this is an example of a y-intercept. And here, we also have something called holes. Now, holes are also an undefined scenario. However, the difference is that the graph is undefined only at a point. So at that point, we call it a hole. So you see that this is an example of a hole and it's not filled in. Whereas my point here is colored in. So that hole indicates that my function is not defined at that one point. So that's what a hole is. And a slant asymptote is similar to a vertical or horizontal because, again, on the asymptote, the function is not defined all along that line. It's just slanted. So this is an example of a slant asymptote. And we're going to talk about how you determine all of these things, okay? So let's compare vertical asymptotes to holes. They both create undefined scenarios. However, as I was saying earlier, a vertical asymptote creates an undefined scenario all along a line, an entire line, where a hole is just undefined at a point. So they're slightly different. So we know that when we look at a rational function, something is undefined when the denominator is 0. So I'm going to look at my denominator here and I see I could factor it. So the first thing we should always do is try to factor things because then if we can simplify it, it makes it easier for us. So I see that when I factor this, I will have a situation that creates 0 in the denominator when x equals -1 or when x equals +1. Either of these solutions will give me a 0 in the denominator and make this undefined. So that means I have vertical asymptotes at x equals -1, which is a vertical line, and at x equals +1, which is also a vertical line. And we would draw those with dashed lines, right? Here, if you look at the second one, I'm going to factor, again, always factor, because we want to factor and see if we can simplify. My numerator is going to factor into x plus 2 and x minus 1. And my numerator is going to factor into x plus 2 and x minus 3. Now again, if we have 0 in the denominator, that creates an undefined scenario. So I can see here that x equals 3 is going to give me 0, and x equals -2 is also going to give me 0. However, the difference between the second situation and the first one is, do you see that I have an x plus 2 here and I have an x plus 2 here? So because I have a common factor that cancels out, that creates a hole. So that common factor in both the numerator and denominator, create a whole. So that's different than the first example because I didn't have any common factors over here that could cancel out. Here I did. So since that x plus 2 creates a 0 in the denominator and it has a common factor, that undefined scenario becomes a whole. So to find the whole, I have to look at this x equals 2. And remember, a whole is a point. Whole is a point, so I have to find the coordinates of my point. So I already have the x coordinate, it's -2, which I get from here. So to find my y value, I'm going to take my -2 and plug it in to my simplified function. So my simplified function, after the x plus 2's divide out to 1, is x minus 1 over x minus 3. So I'm going to plug in -2, and I get -2 minus 1 over -2 minus 3, which gives me -3 over -5, which is positive 3/5. So the y coordinate of my whole, is 3/5. So this is my whole. And at that point, my function is not defined. And I also still have this that I have to deal with. This, x equals 3, I'm going to change the color here. X equals 3 is a vertical asymptote. So I can't forget about that. So there's two things going on in the second problem here. I have a whole, and I have a vertical asymptote. For the first one, though, I only had 2 vertical asymptotes here. No wholes, because I had no common factors, okay? All right, let's move on. So how do we determine x and y intercepts? Well, that's the same way that we would find an x and y intercept for any function, right? If I want to find an x-intercept, I know that y is equal to 0 at that point. So that means y, or f of x, actually let me write this down here. To find x-intercepts, we know that y, or f of x, must equal 0. So that means I want to set this equal to 0, or I want to set my f of x equal to 0. So that means I'm going to get x squared plus 3x minus 18 over x minus 9. I want to know when that's equal to 0. So I really don't care what this is. As long as my numerator is 0, then the whole thing is 0. So basically I'm setting the numerator equal to 0 and solving. I can factor that into x plus 6 and x minus 3. And that tells me then my x-intercepts are -6, 0, and, I don't know what I just did, and positive 3, 0. Okay, now to find the y-intercepts, that's the opposite. We know that x has to equal 0. Okay, so that means I'm going to take my function and I'm going to substitute in 0 for all the x's. So I'm going to get 0 squared plus 3 times 0 minus 18 over 0 minus 9. That's going to give me negative 18 over negative 9, which is positive 2. So then my y-intercept, oops, let me write that a little better. My y-intercept is 0, 2. Okay, so how do we find slant asymptotes? So if you read my little explanation on the top, slant asymptotes occur when the degree of the numerator is exactly 1 degree higher than that of the denominator. So if you look up here, my degree is right here. So this is a degree 2, that polynomial. And here, this is a degree of 1. Do you see that the numerator is exactly 1 higher than the denominator? When in that situation, I have a slant asymptote. So to find my slant asymptote, you have to do division. So you're basically dividing x plus 1 into x squared minus x. You're doing long division. Okay? So I'm going to do my long division. X goes into x squared x times. X times x is x squared. X times 1 is positive x. I'm going to subtract. And those cancel. And here I'm going to get negative 2x. I have a 0 here, so I'm going to bring that down. X can go into negative 2x minus 2. So that's going to give me negative 2x when I multiply negative 2 times x. And then negative 2 times positive 1 is negative 2. Subtracting, these cancel, and I'm left with positive, let's see, 0 to positive 2. So my q of x, my quotient, that's what I'm looking for, is x minus 2. I don't care about the remainder. So my slant asymptote is a line, an invisible line, a dotted line, but it still needs to be in the form of a line, y equals mx plus b. So my slant asymptote, here, let me go back here for a second. So your slant asymptote is q of x. Which is y equals x minus 2. Okay. Finding horizontal asymptotes. So there's 3 scenarios. Either the numerator has a larger degree, and if that's the case, there's no horizontal asymptote. If the denominator has a larger degree, then my horizontal asymptote is y equals 0. If the degrees of the numerator and denominator are the same, then you have to divide the leading coefficients, and whatever that answer is, y equals that number is your horizontal asymptote. So let's look at an example. I'm going to put it all together, okay? I have my function here. The first thing I'm going to do is factor and simplify. I always want to start with that. So I can't do anything with the numerator, but I can factor the denominator, and that's going to be x plus 4 and x minus 4. That's going to give me 1 over x plus 4, because I have a common factor here that cancels out. When I have a common factor, top and bottom, that creates a whole. So the first thing I want to look for is the whole. I know I have it on the bottom here, but you should always look for the whole first. So since x equal 4 is what's creating my whole, I know the x coordinate of my whole is 4. Then I have to find the y coordinate. So I'm going to plug 4 in here, and that's going to give me 1 over 4 plus 4, and that's 1 over 8. So the y coordinate of my whole is 1 over 8. So now I found my whole. Okay. Now the next thing I want to do is find my x-intercepts and my y-intercepts. So the x-intercept, remember, we have to set the numerator equal to 0. Wait, hold on a second. To find my x-intercepts, I want to take my simplified function here and set that equal to 0. So x-intercepts, I need to set 1 over x plus 4 equal to 0. Since my numerator has no variables in it, I can't do this. So that means I have no x-intercepts. No variable in the numerator, I can't set it equal to 0 because 1 doesn't equal 0. That doesn't make sense. So I have no x-intercepts. My y-intercepts, I'm going to replace all my x's with 0, which gives me 1/4. So I do have a y-intercept at 0 and 1/4. Okay? And by the way, after you simplify, like I took my function here and this simplified into 1 over x plus 4, this is the function that you use to figure out all of this. You don't use this one because you simplified it to the new one. So, vertical asymptote. Yes, I have a vertical asymptote because my denominator will be undefined when x equals -4. So that's my vertical asymptote. Then we're going to determine the horizontal asymptote by looking back here. And my denominator has a larger degree. Do you see that the denominator here has a degree of 1 and this has a degree of 0? So my denominator has a larger degree. So that is this scenario here. So that means my horizontal asymptote is y equals 0. Automatically, if I have a horizontal asymptote, I don't have a slant because you can't have both. You either have a horizontal or a slant. Can't have both. It's either one or the other. And the slant asymptotes, automatically the degree in the numerator has to be higher, right? So when you look at that, if the degree in the numerator is higher, there is no horizontal. So automatically you can't have a slant and a horizontal at the same time. All right, I'm going to do one more and then I'm going to leave the other two for you to try because there's, let's see, there's one more. So you know what I'm going to do? I'm going to stop here and I'm going to let you try this one for homework. This will be homework number 1. Just to try the best you can. And this one will be homework number 2 because I also don't want this video to be too long. So you're going to try both of those. Don't forget, the first thing you want to do is factor and simplify if you can because you want to look for the wholes first. All right, look for the wholes first for both of these. And then you're going to take your simplified function, and use it to determine the rest of the characteristics of the graph, okay? All right, guys, see you Thursday.